Thank you for coming. What I like to introduce today to you is a little bit of a different concept for CNC multi-machining. ZPS has been making multi-spindle machines since a long time. If you see, we started in 1951, and in 1996, a couple years after the Iron Curtain came down, we came out with a new model of CAM machines, one of the machines you see in the back over there. And in 2016, we developed and introduced our fourth CNC multi. It's a new approach to CNC multis because the machine has some different features. It is the first 5-spindle CNC multi with Fanuc controls. Why 5 spindles? The reason for this is because we have several good competitors globally that have already made 20mm machines and so on with 6 and 8 spindles for very high complex parts, and they're all good machines. We are looking not at the parts that have 180 design features to measure. We are looking at parts for this machine that have in between 30 and 50 features, because we think there's a big market in this country where we basically have parts that are medium complex on difficult to machine materials. So the concept came and we were asked, how can we make a fast and very economical machine? It's very simple. If you want to make it fast, my principle was always on the CAM side, and John, our expert from the CAM machines, will tell you that, if it can be made on a Davenport, don't touch it. So we came and used that same principle of a 5-spindle, and we used an indexing time of 0.4 seconds and came out with our TMZ and TM 518 machines. The difference between both machines is very simple. One has a independent spindle drive with C-axis on all 5 spindles, and the other model has a central spindle drive for all spindles, still all cross-lights, full CNC. The machine, in its overview you see here, we don't need to go into too much detail. I'd rather go into technology. The machine goes up to 8,000 RPM. On all slides, we have 5 spindles, and we have a Y-axis with up to 3 tools in each position. In position number 2, position number 4, and in position number 5, which is cutoff and back working. So in all of these 3 positions, we can have VDI 20 quick change tooling with coolant through the spindle. The TM 518 CNC is a machine that you see there, has one central drive for all 5 spindles. You actually can use in position 1, like you used on the CAM machine, still your form tools, because we have 47 Newton meter of torque at 1500 RPM, which makes it a very strong machine. The difference to the TMZ 518 is the independent spindle speed. On the TMZ 518, we basically go and have also a very high torque, but we have, in comparison, independent spindle speed and C-axis in every position. The machine itself is based on a weldment on the bottom, which contains the control cabinet, plus 2 vertical columns, left and right, and a bridge on top. So when the machine gets hot, it doesn't dilatate. The drive system on the TMZ 518 is explained in a little movie. I explain you because this is something very unique from ZPS compared to all other manufacturers. Our independent spindle drives in the machine, here on this 518 machine on the top, is different than any other. And that's why we can also build machines with 8 spindles up to 2 3/4 inch full CNC. A short movie explains you how we drive the machines. Okay, hopefully it's coming up in a second. Our drive motors are in the back of the machine, not in the spindle drum. Okay, you get it? Okay, now it's coming up, but it's not coming up on the screen. There you go. You have the spindle motor at the end. I come over here. Connection through a hollow carbon fiber shaft into the spindle drum, driving the spindle. and you have 5 concentric hollow carbon fiber shafts that turn each spindle individually. In this case, it's a 6-spindle rendering, I know, so you have 1 extra spindle. But in general, it's the same concept. Okay? Let's do it again. Can we do it again? Thank you. So, 2 questions that always come up. Because this is a gear drive system, how do you get rid of backlash? 2 things. Number 1, we have, of course, an encoder on each motor. When we do exact positioning, each spindle has its own disc brake and event. So we come 3 degrees prior exact positioning in C, then we have a second encoder on the individual spindle, and so-called, we basically touch the brakes and preload the bearings and position in 0.03 degrees precision. That's why we have a much more tighter resolution than any other CNC multi. So we have 2 encoders, 1 on the motor and 1 on the spindle. The advantage with having the disc brake in the back also allows us, because we have a Y-axis, to do full milling across on Y and breaks the spindle not only electrically but also mechanically. Thank you. Let's move on. Any questions for that? Good. Next slide. Okay. There you see the spindle drum. Also, our spindle drum is we call it a cold drum. The spindle drum doesn't have anything else inside its drum other than spindle bearings and the spindle. Why is this important? Because the moment you have heat in the spindle drum, your center of the spindle will walk. You have to cool it and bring coolant into the spindle drum. You also have to bring electricity into the spindle drum if you have drives inside the spindle drum. So all of that in a rotating spindle drum makes it very complex and unique. Our spindle drums are not unique. They are very standard, and they are called cold drums. That's why they hold precision very well. The machine without covers, as you can see, in the back you see the motors on the opposite side of the cutting tool area, complete away from anything that's hot. And in addition to that, all our motors are standard Fanuc controlled. Here you see a view of the front side of the machine. We have spindle position 1, 2, 3, 4, 5, and the Y-axis in position 2, in position 4, and in position 5. All tools on the Y-axis are VDA 20 driven and coolant through the spindle. And you can individually choose high pressure or low pressure coolant through the spindle. You don't need to have any coolant lines inside the machine. So whenever you have a high pressure coolant tool identified, let's say on position number 2, you want tool number 1, only tool number 1 will have high pressure coolant. All the other tools on the same slide will not have high pressure. That allows you to have full capacity on your high pressure coolant system. The compound slides have a working stroke in Z of 130 millimeter. The maximum part length for this machine is in single feet 90 millimeter. The compound slides in 2 and 4, all of them are on linear guideways. And again, there are no coolant lines inside the machine because the coolant is basically coming through the tool holder. Go a little further. Backworking, usually a weak point of all multi-spindle machines. The 2 things that define a multi-spindle machine cycle time are usually roughing in position 1 and backworking. Roughing in position 1 can be excelled in this machine because we can use form tooling to rough. We can use up to 1 inch wide form tools to go down on 3 or 4L stainless from 19 millimeter all the way to 5 millimeter. In position 1, because we have the torque. In addition to that, we also have up to 3 tools on the backworking, driven. Now, I mentioned initially, we have this machine conceptually based for simpler parts. Not easy parts, but simpler in terms of how many features. So in order to do this, you need to have a fast cycle time. Everybody knows the Davenport bench shank turning attachment on the back working. We have the same attachment here, and we can realize cycle times of 3 seconds and less using the bench shank turning attachment for ID threading. The pickup spindle, spindle number 5, also has 8,000 RPM and 2.2 kW and 22 Newton meter of torque at 1,500 RPM. So it's not just a synchro spindle, it's a full pickup spindle. The parts get ejected, of course, after ejected from the pickoff in the part chute and get outside the machine all the way in the back. There's a little box for the parts on the other side of the machine. And there are 2 versions of the machine. One machine configuration like it's here with a cookie BLT bar feeder, which is limited to 19 millimeter or 3/4 inch, basically ejects the parts to the front. When we eject the parts to the front, we have a half index between 5 and 1 and pick up the bar remnant, put it in a chute, and eject it to the back of the machine. It doesn't get into the chip conveyor and causes the chip conveyor to break. So it doesn't happen here. The other version, which is the TMZ 518 with a cookie BLT bar loader, complete automated bar loader, which pulls the bar into the back, goes up to 1 inch capacity. The drive system I explained already. And there you see the central drive versus individual spindle drives. We also, of course, have a Hurst coupling in the machine. Same principle like everybody has for exact indexing and eliminating indexing error. And all is driven by an electric drive. And the indexing time we're very proud of. As you can see it when the machine runs, is 0.4 seconds. The spindles with the disc brakes in the back, 8,000 RPM. You see the electrical cabinet on this machine is not on the top. It's not on the side. It's in the bottom. Everything that you need for your electricity, for your Fanuc control, is in the bottom of the machine. How is it cooled? Well, we have an automatic chiller, 5-ton chiller, that chills the oil for the high-pressure coolant unit and also chills through a heat exchanger, the control cabinet. So there's no outside shop air going into the machine. The most important thing for us was Fanuc controls. Why? Because Fanuc controls in this country are the #1. Coming from Germany, because of my heavy accent, as you probably realize, we know Siemens. We have Siemens on our CAM multis and also on our other CNC multis, but there's far bigger acceptance of Fanuc in this country. And there's also a far better price on Fanuc than on Siemens. To give you an idea, 70% of all CNC multi cost for material are coming from the controls, 70%. Only 30% of the cost for the material of a CNC multi comes from the mechanics. So if you think that your controls only cost 1/3 of what they would cost from southern Germany, you know that this machine is very price competitive. So coming back now from the control side, the cooling system we talked about, I'd like to talk about the high-pressure coolant system that comes with the machine. We have a 1,500 PSI, 30 gallons a minute high-pressure coolant system, and also a chip filtration system for high-pressure coolant. It goes down to 5 microns. All of those units, including the chiller and the chip conveyor, are integrated in a rack. This rack also houses the bar feeder or bar loader. So when you connect the machine, this is coming as a unit, and it has 2 attachment points to the machine. And then when you install the machine, it can run parts in 2 days after it's being delivered. because we only use 2 attachment points for this rack, and everything else is automatic after that. The bar feeder, also a development by Cookie, a BLT, slides on linear guide rails back in case you ever need to do maintenance on the backside of your machine. This is a representation of the racks. Together with Cookie, we were able to develop this, we call it milestone in the industry, which is definitely on the price competitive side, much less money than if you buy one 8-spindle 22 millimeters or 20 millimeters. You can buy 2 and still go on vacation.